Welcome to the video on how to prepare a calibration report using the Transportation Impact Analysis, or TIA, guidance by the Missouri Department of Transportation. MoDOT has developed a calibration report template that is meant to aid consultants and their parties submitting work to MoDOT in their production of calibration reports. This module will provide guidance and expectations for preparing these reports by walking through each section of MoDOT's report template. The calibration report template consists of 6 sections, shown here. This video will review each section at a high level. MoDOT requires a calibration report to be submitted in conjunction with most microsimulation projects. A calibration report is meant to serve as proof that a microsimulation model has been adjusted to replicate real-world conditions and proof that the microsimulation's ability to replicate real-world conditions has been thoroughly validated using observed counts and measurements. The report template is meant to aid consultants and other parties submitting work to MoDOT in their production of calibration reports. For smaller microsimulation projects, a formal calibration report may not be required. However, the modeler may still be required to outline their calibration processes in the technical documentation they prepare for the project. If a project doesn't require significant calibration, and therefore doesn't merit a formal calibration report, the modeler should also explain this in their technical documentation. Coordination with MoDOT should occur to determine whether a formal calibration report should be provided. It is important that the report template not be altered before submitting to MoDOT. Do not delete any sections of the template. Instead, if a section does not apply to a given project, write NA and give a brief explanation for why that section does not apply. If additional information is needed, it should be attached to the report as an appendix. The template provides several guidelines in color-coded text to represent information that should either be replaced with project-specific information, section explanations, and/or content examples. The first section of the calibration report template is the introduction. This section should be used to give a brief overview of the project, including but not limited to the microsimulation software being used and the anticipated future uses of the model. Section 2 of the calibration report template is model development. This section consists of 5 subsections. The first of these 5 sections is analysis study area. This section should delineate the extent of the model's study area. You are expected to use supporting figures such as an aerial view of the study area with the limits of the area clearly marked in the report. The analysis years section defines the model's base year and the future years for which the model will be used. The analysis peak periods section defines the peak AM, midday, and PM periods that the model considers. This section should also explain warm-up periods that were used, as well as traffic flow rates that were adjusted at regular intervals within the peak period to better reflect dynamic traffic flow. The data collection and preparation section should list the traffic and roadway data items used to develop the model, as well as the source and application of each data item. This section should also give an overview of the base model development procedure. The calibration report template includes an example of a table to communicate this information. Finally, the model assumptions section lists and justifies any assumptions made during the model development process. especially those where clarification would be beneficial and those that deviate from MoDOT recommended values. A table, like the one shown, may be helpful in communicating model assumption information. For this example, the analyst included assumptions for vehicle speeds, vehicle mix data, simulation intervals, and routing decisions. This example table is included in the calibration report template found in EPG 905.3.7.2. Calibration is a way of fine-tuning a model to better replicate field conditions by iteratively adjusting several calibration parameters. A model is deemed to be sufficiently calibrated once it achieves calibration targets that are based on field conditions and agreed upon at the outset of a project, a process known as model validation. Section 3 of the calibration report template details model parameter calibration. This section and its subsections should be used to explain the steps guiding the calibration process and the methodology supporting those steps. There are 5 subsections. The model parameter calibration section begins with calibration procedure. This section should explain the calibration method used, either trial and error or systematic approach, and the procedure related to that method. Supporting figures, such as decision trees, are encouraged if they are useful in communicating the calibration procedure. In the section of calibration parameters, the report should detail the chosen parameters as well as the references used when deciding on calibration parameters. The measures of effectiveness for validation lists and defines the MOEs used for validation and provides an explanation of how those MOEs were selected. If MOEs for validation were previously defined in another document, such as a methods and assumptions report, that document is referenced in this section. The calibration criteria and targets section lists the calibration measures and the corresponding targets used to judge the validity of the model. This section should also include the source of the data and the model results that have been compared against. The calibration report template includes an example of a table that may be useful in communicating this information. Finally, the parameter refinement section lists parameters that were adjusted to calibrate the model to real-world conditions. This section should include written justification for parameter selection for refinement, as well as information on how the parameters were adjusted. This is one example of how to communicate which parameters were adjusted and how the adjusted values compare to the default values. In this table, the analyst differentiates the values chosen based on the analysis segment type. In this example, the calibrated values for parameters CC1 and CC3 are outside of MoDOT's suggested ranges for these parameters. In cases like this, an explanation should be included below for why the calibration values fall outside the suggested ranges. This example table is included in the calibration report template found in EPG 905.3.7.2. Section 4 of the calibration report template is model validation results. The model validation results section should be used to summarize how the selected measures of effectiveness were validated, including the time periods for which the MOEs were validated and the relevant validation targets outlined in Section 3. The model validation results section has 4 subsections. traffic volumes, speed contour plots, travel times, and queue lengths. More subsections may be added depending on the number of MOEs used. We strongly encourage using tables and other visual tools to communicate how model output compares to validation targets. This is an example of a table that relates to traffic volumes and an example of a speed contour plot used to convey model validation results. In the example speed contour plot, the x-axis is location, the y-axis is time of day, and the colors indicate speed. The raw data used to create these summary tables should be provided as an appendix. When possible, include charts, plots, and graphs for both the field collection data and the calibration model for comparison. Section 5 of the calibration report template is simulation runs, and Section 6 is the conclusion. The simulation runs section of the calibration report should document the number of simulation runs performed and show the calculations that determined the appropriate number of simulation runs, if applicable. If an automated tool was used to determine the appropriate number of simulation runs, this section should include the inputs entered and the tool's output. Completing multiple simulation runs is important because it accounts for the variability in traffic flow patterns, verifies model results by minimizing the influence of outlier runs, and more accurately quantifies the results of higher delay and queues. Therefore, ensuring confidence that the sample size of results used for analysis purposes is representative of the true results of the model. The report conclusion should provide a concise summary of the purpose of this document, as well as a very high-level overview of the model calibration and validation process. This may include listing any standards or guidelines which were referred to, what MOEs were used to validate the model, and the intended applications of the validated model. As previously mentioned, appendices may be included in the calibration report as necessary and should be inserted after the conclusion. Appendices should include relevant data and output information that most clearly convey the calibration process and the validation results. Potential appendices include, but are not limited to, traffic data collection plans, traffic volumes reported by the model compared to observed traffic volumes, summary of route travel time validation, summary of link travel time validation, summary of maximum queue length validation, and summary of validation for any other MOEs. We just gave you a lot of information. Let's review the key takeaways. Key takeaways for this module include the purpose of the TIA calibration report and becoming familiar with the TIA calibration report template. There are several resources available to you as you prepare your calibration report. The MoDOT EPG contains an abundance of information about the calibration report. The EPG resources can be seen on your screen. FHWA's Traffic Analysis Toolbox also contains Federal Highway Administration's calibration requirements. Time to see what you know. Question 1. What is the purpose of a calibration report? A. To summarize the procedure and findings of traffic impact studies. B. To serve as proof that a microsimulation model has been adjusted to replicate real-world conditions and has been thoroughly validated. C. To serve as a record of decisions and agreements made at the outset of a project. Or D. None of the above. The correct answer is B. A calibration report is meant to serve as proof that a microsimulation model has been adjusted to replicate real-world conditions, and its ability to replicate real-world conditions has been thoroughly validated using observed counts and measurements. Going through this effort instills a higher level of confidence in our modeling tools and the ability to inform decision makers of the impacts of proposed roadway changes. Question 2. True or false? If parameters were adjusted to calibrate the model to real-world conditions, the calibration report should include written justification for selecting these parameters for refinement. This statement is true. The model parameter calibration section should list which parameters were adjusted to calibrate the model to real-world conditions. This section should include written justification for selecting these parameters for refinement, as well as information on how the parameters were adjusted. Thank you for watching this video on the TIA Guidance Calibration Report. We encourage you to view the other TIA Guidance videos. If you have any questions, please reach out to MoDOT Central Office Highway Safety and Traffic.